Origin gents, welcome to CG Reaction, and this is The Universe in 4 Minutes by the channel exurb1a. Exurb1a is a great channel. I reacted to some videos from this channel and it was just awesome. This is Universe in just 4 minutes. This must be interesting. How he's going to, cram everything in just 4 minutes is just, ridiculous. I saw, Bill Wood's video about, about everything or whatever the title is. And that was much longer than 4 minutes. So let's see how he crams up everything in just 4 minutes. And people, remember, if you like my reaction, don't forget to like and subscribe and support this channel. Check out my other reaction I did. There's a link in the description. Check out the cards for all the playlists I've created. Check out the end cards. Let's watch this one.
Alright, welcome to the universe. We'll start with the Tyrion Lannister of physics, the Planck length, which is the smallest thing you can sensibly talk about. Probably. Next up, we lose our subatomic particle virginity and meet our first neutrino.
I love that, probably. Anybody who's talk about science must always keep the door open.
She's lovely, and she has lots of friends. There are around 65 billion of them, passing through just 1 square centimetre of Earth every second. Up next, we bump into quarks. These come in 7 flavours: up, down, strange, charm, top, bottom, and banana.
Strange.
These are about as close to the building blocks of nature as we've managed to get so far. Next up, we get to the A-list celebrities of the subatomic world: Derek Neutron and Barbara Proton. Usually they engage in a three-way with Carmen Electron in a kinky arrangement known as atoms. Funny thing about subatomic particles, sometimes they behave as waves, other times as particles, depending on how they're feeling and whether or not they're...
Double slit experiment. That's just really weird to see that. I saw, I researched really deep. I saw a lot of videos on YouTube about it. I researched lots of papers too. It's really fascinating, man. Double slit experiment. It's just ridiculous to see that. Quantum physics came and just screwed everything up. I mean, obviously it explains a lot of things, but it's really strange. It's harder to wrap your mind. The day we understand quantum physics properly, that's the day where we're gonna transform into a whole another civilization. Because that's really effed up. Because usually everything in the world follows a certain pattern up until we go to the smallest of the small in quantum physics. Then everything changes. It's just weird.
They're on their period. Which brings us to some more celebrities you will have heard of, such as helium, hydrogen, carbon, and cesium. All of this stuff so far, and everything in the universe, is controlled by 4 forces. The strong force, which generally binds quarks, protons, and neutrons together. Then there's the weak force, which regulates radioactive decay. The electromagnetic force, which holds atoms and molecules together, basically. And finally gravity, who is the promiscuous hussy.
This is also the way he says strong force, Arnold Schwarzenegger, weak force, the Star Wars thing, the prequel Star Wars that people hated. The electromagnetic force, Magneto, and gravity, as it said, Bullock. Man, he should have used the, actual scene image from the gravity, where he has bangs, and bangs are always pointing downwards. I don't know who was that made big issue. I think it was Neil deGrasse Tyson, if I'm not mistaken. It was like, she's in space and her bangs are always pointing down. I mean, that is true, isn't it? Whenever you see, some videos from International Space Station or wherever, people's hairs are just all around. It's not going down. And her bangs are always down. That was just ridiculous.
Of physics and regulates everything else like universes, but we'll get to that later. All this stuff is contained in a neat little package called the Standard Model and is about as close to a theory of everything.
Up, down, charm, strange. Strange. Strange is a scary thing, isn't it? Strangelets. So, if you don't know, strangelets are these, things that they're containing strange matter. So, it's not really, anybody hasn't detected them, but it's theoretically possible. So, imagine a star is made of strange matter. A star explodes with supernova. And all the matter scatters all around in the universe. If those matters interact with our matter, it will change it into the strange matter. So basically, strange matter, whenever it touches our matter, changes our matter into strange matter. It's just weird, like spooky thing, man. So if there was just a shower of strange matter coming toward the earth, we are screwed. Everything from earth will change into strange matter, obviously, which means we'll die. I mean, that's just, that zombie movie type of thing. I don't know how to say, it's just horror movie type of thing when you think about it.
Everything that we've managed to get so far. Generally, little stuff comes under the title quantum physics, and big stuff comes under generally is about as close to a
Higgs boson. That was recently discovered in a large hadron collider. I love string theory because string theory is, lots of people think is really simple. Tying everything together, that sounds like that's way too simple and it's not going to work, and probably it won't. But think like this, there are lots of fields in science people research one field in science and they get stuck somewhere about something, or they don't realize that there are something to discover there because they can't. Because maybe answer to that is linked in some other field of science that they are not going to, because they are only studying that particular field of science. What string theory does is tying everything together, so that way even if string theory doesn't come to be true, like everything can be explained simply like that, even if that's not true, string theory will eventually explain and discover lots of things that otherwise nobody would have, because that includes looking into different fields too. So string theory is really important in that way. And people are saying that string theory, people are coming with lots of theories of it, but there is no actual practical experiment that anybody has done. But the thing is, in string theory, the experiments required immense level of energy, like a large hadron collider. That's very small. You need massive particle accelerator that you have to make in space or something. That's how big it is, and nobody's doing that. Nobody's going to do that for a long time. So that's why it's just theoretical. In US, they were building a bigger particle accelerator that was much bigger than the one in Switzerland, but that got cancelled. But even that wouldn't have been bigger enough to discover all these things. That still would have discovered something like Higgs boson. But yeah, what the hell. Science always gets pushed down. People think we are making all discoveries in science, but people are not spending nearly enough in science and science discoveries than they are spending in other areas. So this is going to be slow, but one day everything will come together. One day.
The theory of everything that we've managed to get so far. Generally, little stuff comes under the title quantum physics, and big stuff, which we'll get to in a moment, is known as relativistic physics. Scientists are working very hard on getting the two of them to move in together, but currently they have severe commitment issues. A little further up, when we get to the code of life, deoxyribonucleic acid, also known as DNA, is made of a sneeze called ATG, or adenine, thymine, cytosine, and guanine. Depending on how these are arranged, you can get anything from the Ebola virus, to papyrus, to the German iris, to Miley Cyrus. Up some more, and we get to cells, some top favourites including red blood, white blood, dendritic, and soft. The next level above that should be familiar. This is where we find raindrops, blue whales, hacky sacks, red tube, the human race, as well as Norway. Out a little further, and now we're looking down on all of human history, including all of your insecurities, mortgage repayments, and ex-sexual partners. Which reminds me, Natasha. You're a bitch. Great. Moving on, we get to the 8 planets and 146 moons of our solar system, which doesn't count Pluto, because you're not a planet, Pluto. You're done, mate. It's over, yeah? Then there's the Sun, which is a 4.5 billion year old burning ball of hydrogen and helium. Several billion years from now, the Sun will rage quit and turn into a red giant, gobbling whatever's left of our planet by then. Out again, and we find the Milky Way. The Milky Way contains...
When our Sun does turn into massive, giant ball, some theory differs. Some theory says that it will touch our planet but won't consume it. Some theory says it will consume it. But either way, even if it just barely touches our planet is screwed. All of us are screwed. The atmosphere and everything screwed way before that. So it doesn't matter if it's going to consume it or not. Earth is done at that point.
Contains at least 100 billion stars. Stars can be by themselves or orbiting each other, called a binary star system, or occasionally a group of 3, which is called a trinary, ternary, or menage star. And that's not all. There's also nebulae, which are little starry wombs where lots of stars are born, moons, which either come from planets or random floating matter, and comets, meteors, and a million other types of astronomical bodies that there simply isn't time to talk about. At the center of our galaxy, and lots of other galaxies, are black holes. These are enormous wells of gravity that suck matter in and distort time. Fun fact, if you held your breath while falling into a black hole, you would die, obviously. And then there's the rest of the universe. The Milky Way, our galaxy, is one of at least 100 billion galaxies, each one prettier than the last. Since there are 100 billion galaxies, with at least 100 billion stars in them, that means there are at least 100 billion trillion stars in the universe. No. The universe itself, as far as...
I think it's quintillion or sextillion, that's the number of total stars, if I'm not mistaken.
As we're aware, is about 93 billion light years across, or to put it another way, if you were travelling at the speed of light, 300 million meters per second, it would take you 93 billion years to get from one side to the other, except for the fact that the universe is expanding, and the expansion is getting faster, which literally makes no sense. And yeah, that's about it, really.
It makes sense. I mean, the space itself, nothing can be faster than light, but that doesn't apply to the space itself. Space itself can expand faster than light.
Oh, except there might be parallel universes and hidden dimensions of space. and we completely forgot about time. The universe began, if you can call it that, about 14 billion years ago, and the first few galaxies turned up a few hundred million years later. A few hundred million years after that, you get the Milky Way, another few and you've got a very young Earth, then oceans, then life a bit later, reptiles, dinosaurs, game over for dinosaurs, sorry chaps, evolution of hominids, and finally all of our bullshit here. Or here, or here, maybe? It's kind of hard to tell because we're so insignificant.
Yeah.
Anyway, nothing means anything and we're all gonna die. Bye then.
That is the most true thing ever said. So that's how we covered in 4 minutes. Just scientific fact, nothing detail about the creatures and things like that Bill Woods did. That was still awesome. The way his jokes and the way he explained it was just awesome. Yeah, universe in 4 minutes. I mean, the thing about expanding universe is that it's expanding so fast, and people are saying, faster than the speed of light. FTL drives, as in TV shows tells us, basically going through, warp hole or whatever, and just going faster than speed of light that way. I think that's just a bit too much over there. Lots of scientists also believe that that's probably not possible. So going faster than speed of light is kind of gonna be impossible. I mean, nobody uses impossible in science, obviously, but still, I think it's not possible. And the space itself is moving faster than light, so there are certain places that regardless of how many time it passes, regardless how much you try, you will never be able to go there, let alone go into the whole another universe. Even if there is multiverse, we'll probably never know about it. People like to think we're discovering this thing, so surely we could visit that, or some point where we could do that. But I think just because we can discover it doesn't mean we can be able to go there or explore that scenario, because there must be a science that let us do that. That's not really entirely true. There could be limitation where we get stuck like this. We can't go beyond that. Even though we know there could be something there, we can't go there just because theoretically it's possible. But the point is, future is great now. I think we are going to be at least multi-planetary species in few decades. The way people are exploring, lots of billionaires, and even now because of billionaires, I mean, first obviously Elon Musk I'm gonna go to Mars. Then Amazon went got inside that, and now lots of other billionaires are too, we are gonna try to put colonies here and there and things like that. Now obviously that puts pressure on government, so NASA's also we are gonna try to colonize Moon and Mars. So this is good, because here's the thing, 30+% of our GDP exists in the world, of entire world, 30+% of GDP, if not more, because NASA was going to the moon with the Apollo program. Whatever discovery they made to make it easier to go to the moon, those discovery helped fuel 30+% of GDP of the whole world. So going to the space, regardless of what is the reasoning, we'll always discover something that will make our life great for coming few decades or even centuries. So it's good people are trying to do that. Future is good. But then again, there are lots of things like global warming and things that are also telling us future could be disasters too. So who knows? Well, I guess keep your chin up. Obviously, we are going to die eventually, but maybe, hopefully, before we die, we are going to witness something great. Alright, people, if you like my Rickson food, like and subscribe, and I'll see you next time.